Graphing quadratic functions. Make a table and graph, find and label the vertex, axis of symmetry, and x and y axes. We're going to start off with a fairly simple one. Now, some students remember something about the vertex and there's some formula, negative b, blah, blah, blah. You cannot use that unless you prove it. What I want you to do is understand what's going on here. So in terms of making a table, we'll start off and we'll pick a negative, 0, and positive. So we plug it in. Negative 1 squared, 1, minus 2, minus 3, and that gives us negative 4. 0, that's easy, you just get negative 3. 1 plus 2 minus 3 gives us 0. Let's plot these. Here's 5. Make sure we label our scale all the way around. We have negative 1, negative 4, 0, negative 3, and then 1, 0. At this point, I want you to think, where's the vertex? Look at those points. What's happening to them? Do you see how they're getting closer together as we're going towards the left? That would indicate that we're getting closer to the vertex. So let's plug in some more negative numbers. Negative 2, and we'll say, so that'd be 4 minus 3, so we get negative 3. What do you notice about what do you notice about these numbers? We have negative 3 and negative 3. That's telling us that the vertex is going to be at the midpoint of these two x values. When you look at plotting this point, every single point on the parabola has a matching pair except the vertex. So as soon as I find a matching pair that are at the same y level, the vertex is going to be, if I think of a horizontal line here, the vertex will be at the midpoint of that line. So the midpoint of 0 and negative 2 is going to be negative 1. Now, in this particular one, I don't really need to write it, but I could say the x value actually of the vertex equals 0 plus negative 2 over 2. But we already know that's negative 1. Here's our vertex. Now let's plot another point, keep on going without actually plugging in the value. Notice here, if I'm going over 1, I go up 1. I'm going to go over 1 and up 3. So it's going to be the same. Over 1 to the left, up 1, over 1, up 3. Just out of curiosity, what do you think it would be if I go over 1 again? I went up 1 here and 3. It's actually going to be 5. Let's connect these dots in a smooth curve. And you really only have to have 5 points. There's a lot to that idea that I just mentioned in terms of what to go over and up. And we'll hit that more later on. And try to make it an even on both sides so it looks symmetrical. Let's draw our axis of symmetry. And now we need to label some information. The axis of symmetry is a vertical line. Recall, we've already worked on vertical lines. Those are always of the form x equals. So it's x equals negative 1. Our vertex is negative 1, comma, negative 4. Look at the coincidence there for the vertex. X value is negative 1, and the axis of symmetry is negative 1. Is that a coincidence? No, I think not. Here's our y-intercept. We have our axis of symmetry. I mean, not our axis, our x-intercepts. Let's go around there. X-intercepts. Now, how would we find our x-intercepts if they didn't come out so nicely on our table? Remember, our x-intercepts, every single point on the x-axis has the same y-coordinate, and that point is 0, or that value is 0. So we could plug in 0 equals x squared plus 2x minus 3. That can be factored to x, and then what multiplies to give us negative 3 but adds to give us 2? Well, the only thing that multiplies to give us 3 would be 3 and 1. The 3 would be positive and the 1 is negative. So we have x plus 3 equals 0, x minus 1 equals 0, x equals 1, or x equals negative 3. So those values are negative 3 comma 0 and 1 comma 0, and we have that in our graph as well as in our table. Did we do everything it asked for? So we found and we didn't label the vertex. Here's our vertex. We've done our axis of symmetry. I didn't actually label it as axis of symmetry. We've done our x and y intercepts, and so that's it for number 1, and see the next video for number 2.